Okay, continuing question 5 of the trigonometry problems. We're asked to solve for x. If cos of x is equal to 1, we're looking for all the solutions that are in the interval from minus pi to pi. One value of x that will make the cosine function equal to 0 is, or equal to 1 is cosine of 0. Cosine of pi is equal to negative 1. Cosine of 2 pi is equal to 1. Cosine of 3 pi is equal to negative 1. So these are all trig properties. These are all properties of the cosine function. Cosine is periodic. It repeats on a period of 2 pi. At theta is equal to 0, or x is equal to 0 at that angle, the opposite side of a right angle triangle inscribed in a unit circle, the opposite side is going to have a height of 0. The adjacent is going to have a length of 1. Adjacent over hypotenuse for unit circle has hypotenuse 1, so adjacent over hypotenuse is 1 over 1, which is 1. So that's a really weird right angle triangle with a height of 0 and an angle of 0. And then if you put the right angle triangle on the left hand side, your x coordinate is negative 1. So your adjacent is minus 1. And your adjacent over your hypotenuse is going to be minus 1 over 1, which is negative 1. So that's what's happening there with those guys. Periodic over 2 pi means as we go from 0 to 2 pi, it's that cos of 2 pi is going to look the same as cos of 0. Cos of 3 pi is 2 pi further than pi, so it's going to be the same thing as cos of pi, which is also minus 1. What if we go backwards? What if we go to negative pi? Well, a useful property is even versus odd property of trig functions. Cosine of x is even since cos of negative x is equal to cosine of positive x. Sine of x is odd since sine of negative x is equal to negative sine of x. Tan of x is odd since tan of negative x is equal to negative tan of x. And I invite you to explore the graphs of the trig functions, sine, cos, and tan, to see these reflective properties or anti-reflective properties and then map them back to this idea of even versus odd. So we can use that to say that the cos of minus pi is the cos of positive pi, since even function, and that's equal to negative 1. So there's only one solution. Thus, x equals 0 is the only solution. Inside this interval. So I should cross out the 2 pi and the 3 pi since they're not inside the interval. It's just the 0, the pi, and the negative pi that are candidates. Okay, next question is asking us to solve for the value of x that makes cos of e to the x equals 0 true. And we're only looking for x values that are between negative pi and pi. So cosine of e to the x equals 0 means, I'll put theta here. Cos of theta is equal to 0 means that theta is equal to pi over 2 or negative pi over 2. Those are the two angles at which the cosine function is going to be 0. if we're restricted to look at angles between negative pi and pi. There's more than that because, again, the cosine function is periodic, repeats itself every 2 pi. So there's a whole bunch, there's an infinite number, but if we're restricted to this domain, these are the only 2. So thus, we can say, since e to the x is playing the role of theta, thus e to the x is equal to pi over 2, and e to the x is equal to negative pi over 2. We want to solve for x, so I'm going to take the first one and log both sides. Using ln, using the ln function, special log function with the base of e. So ln of e to the x is equal to ln of pi over 2. The purpose of using a ln is for this cancellation law. So we get x is equal to the ln of pi over 2. That's one solution. Let's see if there's another. Maybe there's not, maybe it's a trick. Also log both sides. Also using ln. So ln of e to the x is equal to ln of negative pi over 2. Same cancellation law. X is equal to the ln of negative pi over 2. But you cannot take the ln of a negative number. Not in this course. You're not allowed to put negatives into logs. You get imaginary outputs, which we don't do. Cannot evaluate log functions at negative numbers. So we don't get that as a solution. We only get ln of pi over 2 as a solution. As you can tell, or as you should be able to tell, these are hard. These are not easy questions. The point of this is not to scare you. The point is just to tell you what does it mean to be very well prepared. Being able to do all of these means you're extremely well prepared, and missing things, this step I don't understand, that step I don't understand, where did this come from, where did that go? That's all stuff you want to be able to figure out now before the course starts, so you can get help with it. You can ask me for help, or you can look for resources to help with the gaps. Okay, next question asks to, again, solve for x, given that tan of 2x minus 1 is equal to root 3, and we're only looking for solutions between 0 and pi. So we have many ways for memorizing what sine, cos, and tan are at different angles. One of the ways is to memorize special triangles. This is the way that I do it. One of the special triangles is a special triangle for 60, 30, 90. So in this very special triangle, inscribe it in unit circle, and the hypotenuse is 1. Sorry, what am I saying? I'm not going to put this one in unit circle. My apologies. I'm going to pick the smallest side. The smallest side is going to be across from the smallest angle. I'll set that smallest side equal to 1. And then the side across from the pi over 3 is root 3. And Pythagorean theorem gives the hypotenuse a length of 2. So what I do is I just memorize this triangle, and then I use SOHCAHTOA to figure out what sine, cos, and tan at pi over 3 or pi over 6 are. And tan of pi over 3 is equal to opposite over adjacent. So that's from your SOHCAHTOA, opposite over adjacent. Opposite is root 3. So the side that's opposite the pi over 3, adjacent is 1. So we get root 3. Thus, 2x minus 1 equals root 3. The argument inside that tan function is our theta. It's our angle. So our angle must be equal to, oh, what am I saying? Not root 3, pi over 3. Sorry about that. It was pi over 3. Thing that we had to plug into tan to get root 3. I'm going to add 1 to both sides. Let's make common denominators. So pi plus 3 over 3. And then divide both sides by 2. That'd be our answer. And there's no other solutions. Inside pi over 2 comma pi quadrant, since tan is negative there. That's from the cast rule. There's more review of trigonometry, some of the basic stuff, how to evaluate the trig functions at angles, how to use the cast rule. There's more review of this material inside the trigonometry worksheet. So don't panic. Don't panic. These are like the harder problems. They're not the easier problems. Okay, and then the next questions I'll continue in a new video.